Section 6.1 Introduction to Ratios and Rates. In this video we will learn about the golden ratio and how to use a ratio to compare two quantities, 3 different ways to express a ratio, the concept of a rate, a special type of ratio, and rates with a denominator of 1. We use ratios to compare two numeric quantities or quantities with the same units. A ratio. A ratio is the quotient of two numerical quantities or two quantities with the same physical units. For example, ancient Greek geometers believed that the most pleasing rectangle to the eye had length and width such that the ratio of length to width was a specific number called the golden ratio, approximately equal to the following decimal number. Architects to this day use this ratio in their designs. There are a number of equivalent ways of expressing ratios, 3 of which we will use in this text: fraction notation, 2 notation, and colon notation. 3/4 is a ratio, read as the ratio of 3 to 4. 3/4 is a ratio, read as the ratio of 3 to 4. 3:4 is a ratio, read as the ratio of 3 to 4. Example 1. Express each of the following ratios as a fraction reduced to lowest terms. A. 36 to 24. To express the ratio as a fraction, place 36 over 24 and reduce. 36 factors into 3 times 12, and 24 factors into 2 times 12. The 12s cancel and we're left with 3 over 2. Thus the ratio of 36 to 24 equals 3 over 2. B. 12 hundredths, 18 hundredths. To express the ratio as a fraction, place 12 hundredths over 18 hundredths and reduce. Multiply numerator and denominator by 100, so we get 12 over 18. Factor 12 into 2 times 6 and 18 into 3 times 6. Cancel the 6's, and we're left with 2 over 3. Thus the ratio 12 hundredths, 18 hundredths equals 2 over 3. Example 2. For the rectangle that follows, express the ratio of length to width as a fraction reduced to lowest terms. Solution. The ratio length to width can be expressed as a fraction and reduced as follows. Place the length over the width, so we get 3 1/4 feet over 2 1/2 feet. We'll cancel the common units of feet, so we're left with 3 1/4 in the numerator, which converts to 13 over 4, and 2 1/2 in the denominator, which converts to 5 over 2. So we're really just dividing two fractions. Invert the second fraction and multiply, so we get 13 over 4 times 2 over 5. Multiplying the numerators, we have 26 in the numerator. Multiplying the denominators, 4 times 5 is 20 in the denominator. 26 factors to 13 times 2. 20 factors to 10 times 2. The 2's cancel and we're left with 13 over 10. Hence the ratio length to width is 13 over 10. Rates. We now introduce the concept of rate, a special type of ratio. A rate is a quotient of two measurements with different units. The physical interpretation of a rate in terms of its units is an important skill. Example 3. An automobile travels 224 miles on 12 gallons of gasoline. Express the ratio distance traveled to gas consumption as a fraction reduced to lowest terms. Write a short sentence explaining the physical significance of your solution. Include units in your description. Solution. Place miles traveled over gallons of gasoline consumed and reduce. So we have 224 miles over 12 gallons, 224 factors to 56 times 4, 12 factors to 3 times 4. The 4's cancel, and we're left with 56 miles over 3 gallons. Thus the rate is 56 miles to 3 gallons of gasoline. In plain speak, this means that the automobile travels 56 miles on 3 gallons of gasoline. Unit rates. When making comparisons, it is helpful to have a rate in a form where the denominator is 1. Such rates are given a special name. A unit rate is a rate whose denominator is 1. Example 4. Herman drives 120 miles in 4 hours. Find his average rate of speed. Solution. Place the distance traveled over the time it takes to drive that distance. So we have 120 miles over 4 hours, which is equivalent to, if we reduce 30 miles over 1 hour, which equals 30 miles per hour. Hence, Herman's average rate of speed is 30 miles per hour. Example 5. Adisha works 8.5 hours and receives $95 for his efforts. What is his hourly salary rate? Solution. Let's place money earned over hours worked to get the following rate. So we have $95 over 8.5 hours. We'll get a much better idea of Adisha's salary rate if we express the rate with a denominator of 1. To do so, divide. Push the decimal in the divisor to the far right, then move the decimal an equal number of places in the dividend. We end up with 950 divided by 85. And we'll round our answer to the nearest hundred. So when we divide, we get 950 divided by 85 equals 11 and 176 thousandths. Rounding, because the test digit is greater than or equal to 5, test digit is 6, we add 1 to the rounding digit, which is 7, and truncate. So 95 divided by 8.5 approximately equals 11 and 1800ths. Hence, $95 over 8.5 hours equals $11.18 over 1 hour, which equals $11.18 over hour. That is, the salary rate is $11.18 or $11.18 per hour. Example 6. One automobile travels 422 miles on 15 gallons of gasoline. A second automobile travels 354 miles on 13 gallons of gasoline. Which automobile gets the better gas mileage? Solution. Decimal division, round to the nearest tenth, reveals the better gas mileage. In the case of the first automobile, we get the following rate. We'll place 422 miles over 15 gallons, divide 422 by 15 to get 28.13, to the nearest tenth, 28.1. In the case of the second automobile, we get the following rate. 354 miles over 13 gallons, divide 354 by 13 to get 27.23, rounding to the nearest tenth, 27.2. In the case of the first automobile, the mileage rate is 28.1 miles per 1 gallon, which can be read 28.1 miles per gallon. In the case of the second automobile, the mileage rate is 27.2 miles per 1 gallon, which can be read 27.2 miles per gallon. Therefore, the first automobile gets the better gas mileage.